Good afternoon, everybody. I hope you can hear me now. I have tried to share content on my screen. I'm not sure exactly. Yes, okay, super. You're looking at the same thing that I am. So good afternoon, everybody. Pleasure to be with you this afternoon and looking forward to sharing with you a little bit of detail of what's behind the Zero E project at Airbus, a little bit about why we're interested in this topic, why we're doing so much on hydrogen, and a little bit about what these aircraft look like and the technologies that we're using. I'm just checking how to. Okay, so sorry, there seems to be some bugs in the system there. I got kicked out and I'm now back in again. So the slide, hopefully, which you're looking at right now, is really a reminder, hopefully, for many of you of what the aviation industry has set itself as extremely ambitious targets for reducing our CO2 emissions between now and 2050. And here what you see is that the industry has agreed a target. Sorry, it just told me I got kicked out again. I'm not sure what's happening here. The industry has set itself ambitious targets to reduce by 50% the CO2 emissions compared to the 2005 levels by 2050. And that's in the context of growth, which we believe will continue even after the. We believe that biofuels are part of the solution. We need to scale up the use of biofuels, which are compatible with today's aircraft. In fact, our aircraft today are already certified to use up to a 50% blend of biofuel. But on top of biofuel, we need to scale up the use of synthetic fuels. And synthetic fuels essentially are of two types. The first type is what we call a drop-in fuel, a fuel that we can use in existing aircraft. And the other type of synthetic fuel is hydrogen, which can be used in its raw form on future Zero E aircraft, which we're planning on bringing into service by 2035. What we also see is a huge and fast evolving societal and regulatory expectation. We have seen that the UK was the first major economy to pass a 2050 net zero. Sorry, it seems to have dropped out again. UK was the first major economy to pass a 2050 net zero emission law. We saw New Zealand following suit in November 2019 with the 2050 net zero emission law. The EU stated its ambitions for the EU Green Deal in December 2019. We've seen Japan in October 2020 stating a greenhouse gas emission reduction plan to zero by 2050. And the dots on the right of your screen are really to highlight that we're very conscious that this trend is going to continue, that society expects us to find solutions to make our activities zero. We believe that aviation has a huge contribution to make to society. As an Irish guy with a British wife living in Toulouse, with children who support the French rugby team, with German cousins, French and Spanish friends. I really see a huge benefit to aviation. At the same time, what we need to do is get rid of the climate. We know that this is what is needed in terms of future business, and we also know that it's a moral obligation to provide the benefits that aviation can provide without its climate impact. The other element of strategic context that's quite important to take into account is that synthetic fuels, so the synthetic fuels I spoke about earlier, whether it's drop-in fuels or raw hydrogen in its raw form, they need to be generated from renewable energy. So essentially what we're talking about is powering the future of aviation with renewable energy. And those of you who've done your calculations will know that we can't put solar panels and wind turbines on top of aircraft. So we need to keep those on the ground while using hydrogen and synthetic fuel as a surrogate for that renewable energy on board the aircraft. And if that's our plan, then it's really important to understand what's happening in the renewable energy ecosystem. And those of you following the discussion about what we need to do to get to the Paris Agreement, not just for aviation, but as a society at large, will know that we're not there yet in terms of renewable energy in absolute quantities. We still have huge progress that we need to make. But what's very interesting to look at is how renewable energy is growing over the last 5 years and what the predictions look like going into the future. And we see that between in the 5 years preceding 2018, for example, wind energy more than doubled. We see solar energy multiplying by 5 at worldwide level. And that is showing us that even in economic conditions which are maybe even less than favorable, so pre-2018, there is massive growth happening in renewable energy. And these figures are about to be published for 2019 and 2020. And we will see this growth continuing, and it will continue to grow, in our view, at an exponential rate as we go through this current decade. And strategically for Airbus, that's important because it means that we will be able to power aviation with renewable energy with this strong growth of renewable energy that we're going to see over the next few years. What's also really important in terms of strategic interest for Airbus is how the hydrogen economy is developing. And Ron mentioned earlier how the hydrogen story has gone almost viral, and it's true. I started on this project in 2017. It got officialized inside Airbus in 2018. At that point in time, there were for sure some signs that hydrogen could be interesting for various sectors to decarbonize, but not the same level of commitment, of communication, of demonstrators, of vehicles as what we see today. There are now 9 truck companies who have either revealed hydrogen concepts or have hydrogen vehicles even currently on the road. The diesel trains are in many cases going to be replaced by hydrogen trains, where it's more cost effective to put hydrogen on board rather than put electrical systems overhead. We see the shipping industry going towards liquid hydrogen, in particular for what are called intracontinental missions. Perhaps the longer deep sea missions won't be appropriate to be covered by hydrogen, but the intracontinental missions look of interest. And we see more and more hydrogen buses being put on the road across the globe because of hydrogen's potential to eliminate emissions. And this is super important for aviation because on our own, we cannot create the hydrogen ecosystem that's necessary. And what's doubly important is how the trucking industry and intracontinental shipping is starting to focus on liquid hydrogen as its energy carrier, which is really what we need for aviation. Liquid hydrogen is the only option for us really for interesting payload and range, and therefore having a liquid hydrogen ecosystem and teaming with trucking, with intracontinental shipping is going to be important to drive the ecosystem in the right direction. What all of this means, the renewable energy growth, which I showed you earlier, the huge commitments from various industries to be scaling up use of hydrogen over the next decades. What it means is that we're going to see a reduction in cost, a significant reduction in cost of hydrogen over time. And that's important because Zero E is not just a technology project. It is about making zero emission flight economic. It's about bringing aviation, accessible aviation to be available and to be economically accessible by everybody. So the price of hydrogen and how it evolves is going to be critically important in our success. And it means that we are working with an ecosystem which goes beyond the usual aviation borders, from renewable energy providers all the way through to liquid hydrogen producers and airports, to really make sure that we can get the right cost of liquid hydrogen at the airports and therefore make zero emission flying commercially interesting. So a little bit on why hydrogen. So hydrogen, if it's produced from electrolysis, which is really the pathway we are encouraging and pushing, it emits no CO2 during its life cycle. It has also the potential to reduce what we call non-CO2 emissions, NOx and persistent contrails. Potentially, it can completely eliminate these non-CO2 effects. And I'll talk about that when I talk about one of the aircraft concepts that we revealed in December last year. And so therefore, hydrogen provides us with the potential to have genuine zero emissions aircraft. Hydrogen is energy dense, certainly compared to batteries, which is the only real zero emission alternative. Hydrogen is significantly more dense. We're talking about orders of magnitude in terms of watt hours per kilogram of energy storage. For sure, it has some complexities in terms of the amount of volume that hydrogen requires to store, and that does impact how the aircraft are designed, but something that looks feasible to be able to master and take into account for bringing these aircraft to reality. And hydrogen is on top of interest because of how we believe the economics of hydrogen are going to evolve over the next decades. we're going to see the cost reducing. We're going to see hydrogen becoming a part of more or less everyday life. If we look at what is required, not just for aviation, but at the global level for us to meet the Paris Agreement, hydrogen is going to be a big part of that story. And so costs are going to come down, availability is going to come up, and we're going to benefit from that in aviation. So a little bit about the concepts which we revealed in September last year. I'll talk about these three first, and there's a fourth one on the next slide. The three concepts are similar in that they all have hydrogen combustion with a hybrid electric propulsion system. So it means that we have gas turbines which are modified in order to combust hydrogen, and inside those gas turbines there's also an electric motor embedded, and that electric motor takes power from fuel cells which are also fed with hydrogen in order to optimize the energy consumption at aircraft level or propulsion system level. Then the aircraft configurations do look quite different. The top configuration is a turboprop configuration. The bottom one is what we call the turbofan configuration, and then in the middle we have the blended wing body. And what I'd say maybe to make things clear is that the blended wing body for sure is a configuration which looks really interesting in terms of ultimate ambition for a hydrogen-powered aircraft. But it is not likely to be the first zero-emission aircraft that we bring to market in by 2035. The blended wing body, because of this extra volume that it has naturally inside that configuration, it is a great platform for storing hydrogen, which has more volume requirements than kerosene. But dramatically changing the aircraft configuration and the propulsion system in one step we see as too much, and therefore what we're likely to have as a first step is a tube and wing type configuration similar to the turbofan or the turboprop aircraft, but with a dramatically different propulsion system. And what you see in terms of numbers here is that the hydrogen aircraft have quite a large range of scope. It means that all the way from general aviation, which many of you have probably seen examples of, all the way up to 100-seat and 200-seat aircraft, hydrogen can help with eliminating their climate impact, and all the way from 1,000 to 2,000 nautical miles in terms of mission. So hydrogen has quite a range of application. It must be said, though, that it cannot go in the first generation of hydrogen technology to long-range aircraft. Long-range aircraft are going to be using synthetic fuel, which is still based on hydrogen. So it means that hydrogen is still important for long-range aircraft, but it won't be using hydrogen in its raw form until perhaps the second iteration of the technology. The next concept, and so the fourth concept that we've revealed publicly, is a fuel cell powered concept. So it means on this concept there are no gas turbines. It is fuel cells and then the electrical energy generated by fuel cells which power electric motors and turn the propellers. In this configuration, there is water as a byproduct of the fuel cell activation, and therefore in terms of climate impact, it can be zero for this kind of aircraft. We're still working on how the technology scales to what aircraft size and what economics we could have with this kind of configuration. And between all four concepts and several concepts that we've not publicized, we're looking at different options in order to decide which is the final configuration that we want to bring to service. So hydrogen is not without its challenges. We're not doing this because it's easy. We're doing this because we think it's the right thing to do. In terms of challenges, for sure, the technology in some areas exists already. So for example, gas turbines have even flown in the past with hydrogen combustion. The US Air Force flew a B-57 in the 1950s with hydrogen. The Tupolev 155 was flown in the 1980s with hydrogen. But we need to bring the weight and cost down, adapt it to commercial applications before it would be ready to be taken on board a commercial aircraft. In terms of regulation, we are not today using hydrogen in commercial aviation, and so standardization, rulemaking, all needs to be put in place in order to allow us to do that. The infrastructure needs to be put in place, and we're working with airports and energy suppliers to even start bringing hydrogen into airports in the 2020s. So we are developing a concept called hydrogen hubs, airport as a hydrogen hub, where hydrogen is used in the 2020s to decarbonize ground applications around airports, and then scaling up and readying the airports for hydrogen usage on aircraft in the 2030s. Airports are heavy logistics hubs. Buses go to airports, trucks go to airports. They are often logistics centers, and of course, aircraft go to airports. So having airports as hydrogen hubs makes sense, not just for aviation, but also in terms of the surrounding ecosystem. And then, of course, hydrogen availability and cost. As the hydrogen ecosystem grows, we're going to see cost coming down. We've seen various projects which are even beating what I showed you earlier as cost targets for hydrogen in the coming years. So I think exciting things happening there, which are going to help us achieve commercial reality for a zero emission aircraft. A little bit about the technologies which are on board the aircraft. I mentioned already that we have gas turbines which are modified in terms of combustion chamber and fuel injectors, and of course the fuel system which provides the hydrogen to the engines. We have liquid hydrogen storage. It's in the non-pressurized zone in these concepts behind the rear pressure bulkhead. We have 2 tanks in order to comply with our safety requirements, which is to keep independence between 2 fuel sources for independence for safety. We have fuel cells which are required in this hybrid electric configuration in order to optimize the propulsion system. Fuel cells can operate at 60+% efficiency. During some phases of flight, the gas turbine is operating at significantly less than that, and so complementing the gas turbine with electric power from the fuel cells can be interesting. We have power electronics and electric motors in terms of technology which allow the conversion of the electrical energy into shaft horsepower that are embedded also in the gas turbines. In terms of architecture, the architecture simplistic view is what you're looking at now. So you have the liquid hydrogen tank on the right-hand side. This is then feeding both the gas turbine for hydrogen combustion and then a parallel path for a parallel hybrid configuration, which feeds the fuel cells, the electric converter, and the electric motor. The combination of the two in a hybrid electric parallel configuration looks very interesting. And the only difference between this architecture that you've just seen and what would be needed for a fully electric fuel cell aircraft is that you essentially remove the gas turbine pathway, which is what we're exploring with the fourth configuration that I shared with you this afternoon. We've established a joint venture, which we communicated on in the last part of 2020. It's called Aerostack GmbH. It's based in Stuttgart in Germany. And this joint venture is a collaboration with an automotive player. It's aiming at taking fuel cells, which are already at quite a high performance level for the automotive industry, and developing them further for aerospace and for commercial aviation applications. I think one thing that this JV perhaps highlights to you is how serious we are about this ambition. This is not just a paper study. This is something that we are strategically positioning ourselves on, which we are investing millions in order to make it happen and bring zero emission flight to reality. In terms of timeline, we have the ambition to bring the commercial aircraft, zero emission commercial aircraft to market by 2035. We plan to have a product selection and finalize all of the concept work by 2025. This will be fed by technology maturation, flight test of hydrogen propulsion systems, and also a lot of work on the ecosystem and airport as a hydrogen hub, for example, which is an important part of the program and needs to be secured in order for us to achieve the entry into service. That's a quick whistle-stop tour of what I wanted to share with you this afternoon. Thank you for your interest. I'm not sure if we have time for any questions. If we do, it would be my pleasure to try answer them.
Yeah, Glen, thank you very much for your speech and your elaboration on this big, hairy, audacious goal that Airbus has set itself. Not easy, and a lot of challenges ahead. We don't have a lot of time for questions, but there was one, I think, burning question from the group of students, which is to take advantage of new technologies. A lot of money is required. Who will be able to fund and afford all this, and will it still be viable and economical?
Yes, it will still be viable and economical. This is clearly our goal. There's no point in doing this if we can't make it economically viable. That's how it will scale. That's how it will have the most environmental benefits. So this is really a key part of the project. In terms of who will be able to afford it, for sure, Airbus is positioning itself to be able to afford it. We will need help, though. We will need help from the national funding frameworks, from the European funding frameworks like Clean Sky. This is an immensely ambitious project, not to be underestimated. And it's one that we're only going to succeed on if we work as an entire European ecosystem to make it successful. I think we're used to looking at ambitious projects happening elsewhere. We have the opportunity to get behind an incredibly powerful project in Europe to deliver zero emission flight to society. I think we're in a leadership position on this topic. It's something I'm very proud that Airbus is putting itself behind, and I think there's a lot of support in Europe as well to make this happen, and that needs to continue to make this project successful.
Thank you very much on behalf of everyone. The Symposium, and congratulations on getting the wind under this project and getting it on its feet. And good luck on your next steps.